And we are live once again. Welcome to another Haas Demo Day Live. This is the August 2020 edition. This is our third time doing it. And as always, we appreciate you all taking a few minutes out of your day to join us. So, a couple of things I want to talk about. First of all, and I say this every month, I'm holding my mask in my hand because when we're not on camera, every one of us has a mask on. So, just wanted to get that out of the way. Toss that aside for now. We're live on HaasCNC.com. We're on the Haas YouTube channel, and we're on Facebook this time, so something new. So we've got Marcus Imes in the back there monitoring all the chat. So if you have any comments or questions, type them in. Marcus will hit you up. We're going to go a little shorter this month. We've got the ST30L to my left, and we've got something we call the TSC Challenge behind me. So a little shorter demo day this month because we've got a big one coming in September. Okay. Let's get started. I'm going to throw it to Andrew and Bob, and you guys are up.
Right on. Thanks, Brian. Hi, everyone. Before we get started here, I just want to say thanks for joining us. We got over 100 people in the chat right now, people from all over the US, it looks like, and all over the world. Thank you, as always, for joining us. So as Brian was saying, we're standing here in front of the ST30LY in this case. So this is Haas's new long bed ST30. There, of course, is also a non-Y version. Yeah. But today we're going to show you a cool thing about using Y-axis in this application. So to begin with, I mean, there's kind of only one reason you're going to get an ST30 long bed, right?
Yes, it's longer.
That's right.
That's
longer.
It. That's it. Right. We can go home now. That's it.
So long parts. Maybe we want to open it now. We'll take a look at it.
Okay.
So luckily we've got this double automatic doors here on this one, so that makes it kind of easy to get to your part. As you can see, we've got this long shaft in here. Tell us a little bit about the travels here.
Yeah, so we basically, the long bed, we've just doubled the Z-axis. So we've gone from 32.5 inches to 62.5 inches. So you've got a lot more room to get longer parts in to your machine.
So it's about double what you're going to get on a regular ST30, right?
That's correct, yeah.
Okay, so let's actually bring this. You want to show us what it's like with the door closed?
Well, the cool thing is, as I close the door, this right door in, the pendant comes with it. So if I look now, we are actually looking at like a regular ST30 on this side. It's got the same X travel. It's got the same Y travel.
Right. So when you're in this position, it's pretty much like using a regular ST30.
Yeah, you can move your tailstock fully back and your steady rest fully back, and you can start working on a regular part that you wouldn't.
If you're doing shorter stuff.
Correct. Yeah.
Right. Okay. Cool. Well, so another thing to mention, I guess, is that with these things all the way open, you've got obviously you've got a lot of clearance. How large a part can we get in here?
Oh, you can go up to 62 inches, 63 inches, and the door opens to about 60 inches, so you've got access to get in there easily with a longer shaft.
Right, and this is 57 inches on this one right here.
This blank is 57 inches long, and it fit perfectly.
So it's getting to about where you're about the usable travel. You get a few more inches here.
Yeah, and depending on your work holding, you can squeeze in a longer part. Yeah.
Right, but with the double doors, you don't have to do a whole lot of winding around to get a longer part in here.
Absolutely, you don't want to be working around that.
Cool. Let me take a look here. Tons of comments from all over the world. Thank you, guys. So let's see. So really, there's kind of two. I'm no expert for sure, but you are. There's kind of two kinds of work you're going to do specifically on a machine like this.
Yeah.
And what are those?
Well, these long shafts that you can't get into a regular ST30, or maybe it's not that long, but you have long tools in the turret where you need to access the Z-axis all the way back so you can work on the face.
And that's when the steady rest here is going to come into play.
Absolutely, yeah.
To support kind of a mid-length part.
Yeah, and then you can work with long boring bars to do the machining from the front face.
Right. Let's talk about the steady rest provision.
Yeah, okay, so the Haas steady rest provision comes with a base, and then you have to find a supplier for the bracket, the mounting block, and the steady rest. Right now we've got Atling, but you can have...
Yeah, there's a number of vendors.
There's LNS and there's Kittigawa, there's a few others. But we've got Atling right now, and it's holding on to a 5-inch diameter.
Sorry, I don't even... so the provision, you get the mounting plate.
This bit here, this mounting plate, which holds the steady rest in place.
Right, and then you also, of course, the provision part of it that we supply is the base plate and the hydraulics the extra pedal.
And the pedal, yeah. So you can actuate it with the foot pedal, or you can use an M code and use it in the program as well.
Right. So then what you're buying separately is
the steady rest.
that one there.
Yeah.
Right. Okay. Cool. And I mean, you can get different sets of jaws, right, for this thing?
Different size steady rest, yeah. This one is 20 millimeters to 200 millimeters, so it can go from just under an inch to just under 8 inches. Any diameter in between there, this will hold it.
Cool. Let's talk a little bit. Maybe it's basic for some people, but maybe if you haven't used the steady rest before, walk us through quickly how you go about aligning that thing.
Yeah, there's a short video online already just to show you how to do it.
Maybe it's not online yet, but it will, will be soon.
And there's or you can contact the supplier. Yeah, you can contact the supplier as well. But basically, it's hand tighten the 4 bolts for the mounting block, hand tighten the 4 bolts onto the steady rest. It's not on center, so you just have this hanging off the bolts. Put a shaft in here that is machined with a tailstock supporting it, something sturdy, because what you're going to do is, while that's in there with some indicators on the shaft, you're going to clamp this loose steady rest onto the shaft.
So it's supported by the tailstock.
Yeah.
Right.
So what's going to happen is, as soon as it clamps, it's going to shift to center line. The mounting block will shift, and the steady rest will lift to center line. And then you can clamp your bolts while it's in that position, and retract your steady rest, and you can check with the indicators when you clamp and unclamp to see if it stays in place.
If they're coming back to center.
Exactly.
Right. Okay.
Yeah.
Cool. So I guess next up, now you don't really want to run this raw shaft in here.
No.
On the steady rest, right?
Exactly. We've got the raw stock in here. It's been held by jaws with the steady rest clamping the part right now, but it's not advisable to clamp on raw stock. The material usually raw stock is bent, and it's a rough face, so you can actually move. If I move this at 2,000 RPM now, this will start moving up and down, and the steady rest bearings, they'll start wearing out quickly as well.
Right.
But we've actually used it to center the bar to the chuck and to the tailstock.
Right now, the steady rest is holding this thing pretty much on center.
Yes, it is. Yeah.
And because we have let's first typically. When you're working on often on a long bed lathe, you're going to want to put a centering hole on the end of your long shaft.
In this long, yes, yeah.
And usually you have to do that offline.
Some people do it offline, do a centering head. It's a bit of a pain. But we're going to show you that you don't need to do that with this. You can just put the raw stock in here. We can use a Y instead of spinning the chuck. We can use the Y-axis and the X-axis to punch a hole in.
Let's show them that.
Okay.
So Sal, you wanna head in here? We're gonna poke one of the cameras in here in through the window, so we can see just the first part of it. And then we've also got an action cam in here, so I'd like to kind of catch the second part of the operation as we talk through it here.
Yep. So we're just gonna come in with a center. It's gonna go on center line. Part's not moving. Gonna punch a hole in there. A nice 250 thou center. So that'll make it. Now we've got a self-centered hole there. We've got a tailstock that can come in right now. Can you see this?
The
tailstock's coming in. So now we've supported the part between the tailstock and the chuck. We can unclamp the steady rest.
Okay, so now you're going to come in and...
Now you can actually machine the whole part on the OD.
In this case, you're going to dress...
Yeah.
But let's wait here. I think we can get your camera out of here, Sal, and we can switch to the inside shot.
So we're just going to skim the OD by the steady rest.
So this is going to give us a registration surface for the steady rest itself.
Yeah, now I can safely clamp on that area and send the tailstock home. And
all right, there we go.
Now this is ready to machine stuff on the face, or we can actually unclamp the steady rest and bring the tailstock in and do the OD.
Right, and you've got a nice, smooth, true surface running on axis. Alrighty. So, and another thing you can see here is that we've got really good clearance here in terms of the tooling along X-axis.
If anybody's worried about the steady rest and if it's in the way of other tools, we've got 2 tools next to this turning tool, and as you can see, it's quite clear. If it's open and closed, this will clear whichever station you're on. So you can fill up the turret. You're not going to lose any stations.
Right. Speaking, so speaking of clearance,
Yeah.
we've got some rather long tools in here that we need clearance for.
Just a bit, yeah.
So let's talk about one of the other different things on this long bed.
Yeah. Well, by the way, while I'm closing the door, I'm going towards the truck.
Maybe leave it open just so they can see.
Yeah, I'll do that as soon as I get there.
Don't let me rush you.
No, don't worry, Andy. You're not. But the cool thing about this is I've just moved the door. The pendant is on the door, so you're actually working right next to where you want to work with sliding the door to the right position. Yeah. So.
Good point. So on a regular SD30,
this is about as far as you could go with the boring bar stuck out that way.
Because you'd run up against the wall.
The bulkhead. But the cool thing about this is we've got a 24-inch boring bar in there, and I'm right next to the chuck. And because of the extended Z pocket that we've given on this ST30 long bed, which is on the Y and the regular one, you can get tools in that are up to 30 inches long. So yeah.
Right. So you might be doing this intermediate length shaft here.
Yeah.
Using that long boring bar up to its full capacity, and yet you can still get all the way in here.
Yeah.
Because you've got all the clearance you need there.
And there's enough clearance for 4 stations back there, so you can put at least 2 long boring bars in there.
Right.
And yeah, good to go.
Very good. Cool. Okay, so that kind of wraps us up for this at the moment. We're going to come back to this machine after John and Brian are done, but for now, let's throw it over to John and Brian on the VF2 IT.
Thanks, Andrew. Appreciate it. Hey, I've been following the stream. We've got people from, of course, the US, Canada, Greece, Italy, Spain, Sri Lanka, India, Colombia, Serbia, and Hungary. So thank you, everybody.
That's fantastic.
So I'm here with John Nelson, Senior Applications Engineer, and John's devised something that we call the TSC Challenge, Through Spindle Coolant Challenge. We've got so many options. When you go in and do a build and price on a machine, there's probably almost 100 options. One thing that stuck with me is you told me you would never buy a mill without 3 options: programmable coolant, a probe, and through spindle coolant.
Absolutely.
So we've been practicing this for a few days, and that really stuck with me, and it explains why we're doing this today. So we're going to show you the difference between using TSC and not using TSC, and just show you in terms of straight cycle time, the savings that it gives you.
Yep.
So before we get started, probably noticed we have a bunch of tools on the card here. The tool that you're using for the TSC challenge is from HaasTooling.com.
Yeah. It's a 3/8 inch diameter a drill that has through spindle coolant holes already drilled in it, obviously. And so we're going to show how you would normally drill a hole using a high-speed steel drill versus using a carbide TSC drill.
Right.
And what it can really gain you in terms of cycle time reduction and obviously profit.
Right. So we're going to start with a high-speed or a cobalt drill.
Yeah.
And the cobalt drill, it's not just the drill, you need an additional tool to be able to do it, right?
Yeah, so we have to center drill that hole first because we want that hole to be on location.
That's right.
And the only way you're going to do that with a jobber length, cobalt drill is to center drill the hole first, and we have to peck drill that hole because we need to get coolant down in the hole, and we also need to make sure that that hole is drilled straight. It's one thing to have it on the right location at the top, but it also has to be straight all the way down.
Right.
The drills that we offer are all 5 times diameter length. So you can drill the depth 5 times the drill's diameter.
Right.
And that's what we're doing in the demonstration. So it's 3/8 of an inch diameter, drilling 1.875 inches deep.
Okay. And before we get started on the demo, afterwards we're going to put up some slides. We're going to show you some things. We're also going to talk about tooling costs because tool cost is something that is a factor.
Yeah.
Okay, Sal, do you want to get ready for the demo there? And while you're doing that, let's talk about the specific drill you're using, some specs and coatings and whatnot.
Okay, so all of the drills, so we offer the drills in 2 basic styles, right? One style is for steels and cast iron. The other style is for stainless steel and high temperature alloys.
Right.
Also the drill that's recommended for aluminum as well. And you really, so those 2 styles of drills, the ones for steel and cast iron, come with through spindle coolant holes or without. You can get them without if you don't want them. But the drills that are specifically designed for stainless and high temperature alloys only come with through spindle coolant holes, because you really have to get the coolant down in the cutting zone to effectively drill in those materials. They work harden so easily. So that's the difference between some drills being offered in through spindle coolant and some not. And then there's a size limitation. So the smallest drill that we offer that has holes through the drill for through spindle coolant is 3/16 of an inch, 0.188 inch diameter.
And we've got that here.
That drill is here. So the one that I'm using is designed for the stainless, high temperature alloy and aluminum, and obviously it's a through spindle coolant drill.
And we had a little discussion, almost a little controversy about the coating, because we've done some other videos on HaasTooling.com. You guys have probably seen them. And one of the comments was the coating on the drill, guys were questioning whether we can use that on aluminum or not.
Yeah, so the manufacturer of these drills coats all of them with Talon, which is titanium aluminum nitride coating, and it's widely recognized as the best coating for high temperature applications, which also makes it a good all-purpose drill. The amount of aluminum in the coating does, the theory is that you shouldn't be using that on aluminum, because aluminum will stick to the aluminum that's in the coating. I can tell you from my experience, I've drilled thousands of holes with drills in aluminum with titanium aluminum nitride coating and have not had a problem. I think the issue is that you really have to push that drill hard, and that's exactly what I'm doing in the set.
Okay, yeah, and all your testing was done with that coating, all the drill testing you did.
Absolutely.
So absolutely not a problem. Okay, anything else you want to talk about before we get the demo started?
No, that's it.
No, okay. Oh, hang on a second. Andrew's got we're going to bring a question in from the chat.
Yeah, let me unmute myself here. So this is a question first of all, thank you everyone for joining us again. Nearly 300 people on the stream right now. We got people from all over, of course, California, Colorado, Bulgaria, Mexico, Vancouver, BC, India, Texas. So thank you for joining us. This question came in earlier. Can you field install TSC?
Yeah, that's a great question. John and I talked about that yesterday. Yes, you can field install TSC. You can obviously buy the machine with TSC pre-installed. We have something called TSC ready. So if you're not quite ready to pull the trigger for the cost or whatever reason, you can get your machine TSC ready. It's much less expensive, and all the hoses and everything is already routed. So when you do decide to field install the TSC, your HFO can come in and do it in half a day or less.
Intermediate length shaft.
So good question. Thanks, Andrew.
That's pretty much it.
Okay, you about ready to go there, Sal? Hey, before we get started, we didn't talk about the vise you have.
Oh, yeah. So this is a new pneumatic vise that we're going to be offering soon on our website, HaasTooling.com. This is a pneumatic version, and we're running it through its paces now, testing it out.
Cool. Okay, real quick, explain what you're going to do before we press cycle start, if you would, please.
Okay, so we're going to drill a hole with the high-speed steel. It's actually cobalt drill, and before we can drill that hole, we have to center drill it. So we're going to center drill it first, then drill that hole with the cobalt drill, and then we'll take a look at the cycle time. It'll stop. I'll tell you what the cycle time is, and then we're going to run our carbide TSC drill and see what that does.
Okay, let's do it.
All right.
Sal, you ready to go? All right, let's do it. Okay, center drill first.
Yeah. And here comes the 3/8 inch dauber drill. We're peck drilling, 1 inch, 875 deep. So that program has stopped now, and we're right at 22 seconds on the cycle time.
Okay.
Cycle start again. We get our carbide TSC drill in there.
Okay. Timer starts. There's our through spindle coolant, and there's no peck drilling there.
No peck drilling there. We're going straight to the bottom of the hole. That's 10,000 RPM, 180 inches a minute, 18 thousandths per revolution.
So you just drilled 7 holes, and what's our cycle time at?
My cycle time is 42 seconds.
So that's 21 seconds. So basically, in the time it took you to drill 1 hole without TSC and with a cobalt drill, you drilled
7 holes.
7 holes with the through
7
spindle
times faster.
Yeah. That says it all.
Yeah.
I mean, that's the whole reason that TSC is worth the investment, at least to you. That's why you said you'd never buy a machine without
absolutely. The cost savings, we'll show you in a minute here. This thing will pay for itself in just a few months.
Okay.
Frank, do you have the first slide up there? Great. So this is showing that the high-speed drill with the center drill drilled 1 hole in 21 seconds, and with the TSC drill, we drilled 7 holes in that same amount of time, 21 seconds. Let's jump to the second slide there. And we can see if we take a real world program example, so we had a program that was 2 minutes and 25 seconds total cycle time. 1 minute of that cycle was drilling holes.
Okay.
So we switched to a carbide TSC drill and drilled those same amount of holes that took a minute in 9 seconds. So we reduced the cycle time of this thing 51 seconds down to 1:34. And reduced our cycle time by 35%. If you take an average shop, well, we have a conservative shop rate of $60 an hour, just to sort of make the numbers even. And you ran this machine, you ran these parts for 8 hours a day, you would save $168 each day you ran that job. The tooling cost for this drill is, and you can put up slide 3, sorry. The tooling cost is expensive, right? Somebody's going to say, hey, that carbide drill is much more expensive than the Cobalt.
Yep.
As a matter of fact, it's 10 times more expensive. On hostooling.com, the drill that I'm using that we just demonstrated here is $66.95. The Cobalt drill that I got is available on MSC Direct for $6.50. It's 10 times more. But I promise you, you're going to get 10 times more holes. You're going to get probably 15 times more holes. You're going to way more tool life using the carbide TSC drill with your speeds and feeds all dialed in. So
let's just say the tooling cost is a wash.
Yeah, absolutely. Let's zero that out.
10 times more cost, but 10 to 15 times more holes.
Right. Now, you've got to pay for the TSC option.
Right.
Frank, if you'll put up slide 4 there, we'll show that TSC option is $6,795 on a Haas machine. If you can save $168 a day by drilling holes with the carbide TSC drill using TSC, you divide that into the cost, and it'll take you 41 days to pay back that option. 41 work days is 2 months.
Yep.
Let's say we're overly aggressive on our numbers, 3 months. If it takes you 3 months to pay for this option, how long are you going to own that machine for? How long are you going to drill holes using TSC? So every hole you drill after that 3rd month is pure profit right in your pocket.
Great. And again, that's why you say you would never buy a mill without the spindle cooling.
Absolutely.
One more thing I thought of with respect to feeds and speeds. When we were doing this test yesterday to get ready for this, I asked you if you were using the recommended feeds and speeds from hostooling.com, and you said
not exactly.
Not exactly. So explain why.
So first off, I would highly recommend everybody go to hostooling.com and take a look at the resources that we have for these tools. There's a fantastic chart that gives you all the specifications of the drill. We provide a drawing that gives you all the size information on the drill, right? Obviously the diameter, but you get the drill point angle, the length of the flutes, the shank diameter, all of that stuff on the drawing. The specifications and the coatings and all of that information is there, and then there's a speed and feed chart. You should definitely, those speed and feed recommendations are the general starting point. And when we tested all of this tooling before we offered it for sale, we used those baseline numbers right in the middle, not near the bottom, not near the top, right in the center of the range, and everything cut fantastic. So I'm fully confident that if you get these tools from hostooling.com, plug in the numbers, you're going to make good parts right out of the gate. Now, that being said, you definitely need to dial in your speeds and feeds to optimize the application for whatever you need. Do you need to get these parts out quicker and shorten cycle time? Well then, figure out where you can push it a little harder. If you need that tool to last for another 2 months or whatever it is, then back off a little bit on your feed rate. Whatever it is, but you should definitely be, long run jobs for sure, you should definitely be optimizing your speeds and feeds.
Perfect. That explains why you weren't using the recommended feeds and
yes.
speeds.
And on aluminum, I usually go to the maximum RPM on my spindle on everything and then adjust the feed rate accordingly to that RPM.
Okay, Sal, can you get in position one more time? I just figured we'd show the demo one more time because after all, it is only 42 seconds. So,
yeah, sure.
You ready, Sal? All right, let's do it. Let's do it one more time. So center drill, now we come in with the
center drill,
cobalt drill.
We're using the high-speed PEC cycle from the Haas control on this. And that turned out 22 seconds.
Just like before.
Yeah. Here comes the carbide TSC. Watch this thing punch those holes.
I love that demo.
Yeah.
And once again,
42 seconds.
So 21 seconds for each.
Basic.
Okay.
Yeah.
Thanks, John. Okay, I hope you guys enjoyed that demo. We're going to throw it back to Andrew and Bob. They've got another part in the ST30L. And Andrew, it's all you.
All right. Thanks, Brian. All right. Like Brian was saying, so we loaded up this shorter shaft in here now, kind of intermediate length. And this is an example of kind of the other style of work we'd be doing on a machine like this.
Yeah.
So walk us through kind of what the idea here is.
Yeah, it's like what we talked about before. You can turn the whole OD with a 57-inch long shaft, but when you want to work on a face of a part and it's not that long, we can use a steady rest. The steady rest is
really where the steady rest comes into play.
Yeah, and this is quite easy it's loosen it with that twist there. Slide it to the position you want that's required, and it's clamped down, and I can close the steady rest. Now we're ready to machine this long boring back and do the bore on this. And you wouldn't be able to do this on an ST30 regular. The travel's just not there to get back in far enough for this boring bar.
Right.
Yeah.
So either deep ID or drilling, or otherwise you're gonna be doing face work here, still supported by the steady rest.
Yeah.
Right. Okay, so that's kind of sums that up. So overall, what's different about the ST30L? Why?
It's longer.
It's longer, and it's got the extra stuff like the steady rest, and it's got the deep Z pocket. Great access to the double auto doors.
Yeah.
And that's kind of sums it up. So we're gonna bring Brian back in and kind of walk us out here.
Yeah, let's finish this up. Thank you guys. It seems awkward standing between you. 6 feet.
Well spread out.
6 feet. 6 feet. Thank you guys for joining us. Told you it'd be a short one, but in September, the week of September 14th, that's going to be a different story. As you all know, there's no IMTS this year. We've got a big week planned. We're going to have live streams every day, all 5 days that week. I was talking to John Nelson a little bit ago. I think we have 10 machines that we're going to be walking around doing cutting demos. We're going to be talking about the control, HaasTooling.com, all kinds of things. So please join us there. Check your email, follow us on social media, and you'll get the notifications. So for Bob, Andrew, John Nelson, all the camera guys, appreciate it. We will see you in September. Thank you.
Thanks.
We'll be right back.